Okay, here I'm going to talk about protons, neutrons, and electrons, and how, so these we call the subatomic particles. And by subatomic, we just mean that they exist within atoms. They are the smaller pieces that make up atoms. So protons, neutrons, and electrons. Well, protons are, so we're going to sort of define them in a few different ways. We're going to say whether they're big or small. We're going to say if they have a charge. And we're going to say where they're located. In this video, I'm just going to tell you the answers. I'm not going to tell you how we know any of this information. Later, I'm going to make a video where I talk about Rutherford's gold foil experiment and how we sort of use that to come up with a bunch of this information. Because I'm doing these videos with the intention of grade 9 course, that's as far as I'm going to go. When you get to grade 11 or grade 12 chemistry, we'll talk in more detail about how we know more of this information. So protons. They're big. Their charge is positive. When I want to say positive, I'm going to use the abbreviation positive like that. And they're located in the center, or what we call the nucleus of the atom. This is the incredibly small center. Neutrons are also big. They are neutral, as in they have no charge. And they are also located in the nucleus, or in that massive center part of the atom that's extremely small. So it has a lot of weight, but it takes up very little space. It's extremely dense. And finally, electrons are small. They're about 1/2000th the size of the protons and the neutrons. They have a negative charge. And I will abbreviate negative, similar to positive. And they are located in orbits, is a word some people use, or shells around the nucleus. The shells are much, much bigger than the nucleus itself. 1,000 times bigger to 10,000 times bigger. Okay, so all of that is what we know about protons, neutrons, and electrons. I want to be careful about something. I'm saying these are big and this is small. That's only relative to each other. All of these things are incredibly small. They're way smaller than cells, way smaller than anything that you think of as small. They are actually the parts that make up individual atoms, and there are tremendous amounts of atoms in any sort of material that you would look at. So they're unbelievably small. So when I say big and small, I'm talking about compared to each other. I'm not talking about overall. Overall, they're all extremely small, but electrons are significantly smaller than protons and neutrons. What that means then is when we consider the mass of an atom, we consider these two things when thinking about mass, and we say that this thing has an insignificant mass. Okay, with all that in hand, let's go over to the periodic table and talk about how we can determine in an individual atom, how we can use our periodic table to come up with the number of protons, neutrons, and electrons. On our periodic table, and all periodic tables are labeled a little bit differently, we're going to have two main numbers that we're interested in to help us figure this out. We're going to have the atomic number and the atomic mass. The atomic number on your periodic table is the lower of these two numbers. So if we look for an atom like lithium, and we look it up on our periodic table, we're going to see he has an atomic number of 3 and an atomic mass of 6.9. Now, we're not going to get too distracted here by figuring out which one's which. We just always know that this one's lower, so that's the atomic number. By definition, the atomic number is the number of protons. So in my lithium, 3 and 6.9, I have 3 protons. My atomic mass is the bigger one, and it has to be the bigger one because it's a combination of protons and neutrons, so it has to be more than protons. My atomic mass gives me the average mass of the atom. Now, since I just set up here that I consider my mass to be made up of my protons and neutrons, I can also think of my atomic mass as the total number of protons and neutrons in an atom. So the atomic mass is equal to the protons plus neutrons. Here, for now at least, when we're using atomic masses, we're just going to round these numbers. So that says 6.9. We're going to use an atomic mass of 7. Later, I'll talk about why it's 6.9 and not 7 directly, but for now, we don't want to have a fractional part of a neutron, so to avoid that, we're going to round those numbers. 6.9 goes to 7. So with that in hand, how can I figure out my number of neutrons? Well, if atomic mass is protons and neutrons together, and atomic number is just number of protons, then I can take my atomic mass minus my atomic number. Hold on, I'll deal with that later. And that will be like my protons and neutrons minus my protons, and that will just leave me with my neutrons left over. So here I have an atomic mass of 7, an atomic number of 3, which will leave me with 4 neutrons left over. So those are what those numbers mean and how we can use them to get protons and neutrons. The last thing we have to do to figure out electrons is we have to consider the charge. The simplest thing we can do here is we can deal with neutral atoms. In a neutral atom, there's no charge. And what we'll remember is that protons are positive and electrons are negative. So if I'm going to end up with no charge overall, what that means is my protons are equal to my electrons, and so the positive and negative will cancel each other out, and that's how I end up with getting back to no charge. So if I have neutral atoms, then my electrons are equal to my protons, and that's set to 3 for this particular example. If I do have a charge, instead of calling it an atom with a charge, I call an ion. And with that in hand, it depends on what kind of ion I have. If I have a positive ion, what that means is I have more protons than electrons. So, protons can't change. Those were set by the atomic number, and that's what defines the atom. So if I want to have more protons than electrons, what I effectively have to do is lose electrons. So if I want a positive charge, say of +1, and I have a proton number of 3, then my electron number, to be 1 less than the protons, should be 2. Similarly, if I want a charge of +2, and my proton number is 3, then my electron number, being 2 less, would be 1. Here we can see we would have +3 minus 2, resulting in our charge of +1. Here we would have +3 minus 1, resulting in our charge of +2. Last but not least, so that's positive ions. Last but not least, negative ions. Here we have more of the negative guys, the electrons, than protons. And since we can't change our number of protons, what that means is we get extra electrons. So again, let's say we're dealing with our same guy with the 3 protons, and I want to give him a -1 charge. What that means then, when I'm determining my number of electrons, is I get one extra electron, or one more than the protons. So that could be plus 3 minus 4 for a total overcharge of minus 1. Similarly, if I wanted to give them a charge of minus 2, my proton number was 3. Then my electron number, right, because it's negative, needs to be 2 bigger than that. So it'd be 5. 2 extra electrons. Plus 3 minus 5 gives me a charge of minus 2. So, protons and neutrons are set based on the numbers from the periodic table, and they're always going to be the same for atoms. So we got this 3 and this 7. We do 7 minus 3 to get the 4. Electrons are a little trickier. We got to look at the charge. If they're neutral, which is what we're going to deal with most of the time in this course, we'll say that the electrons and protons are equal. That's what's leading to no charge. If we have a positive ion, since we can't change the protons, but we still want to make sure there are more protons than electrons, that's what made them positive, we'll reduce the number of electrons accordingly. So if it's plus 1, that means we reduce the number of electrons by 1. If it's plus 2, we reduce the number of electrons by 2. And if it's a negative ion, that means we have to have more electrons. So that's easy. Instead of reducing the number of electrons, we're going to increase it by 1 or 2, depending on what the actual charge is. Again, that doesn't tell you why any of that stuff happens. That just tells you how to figure out what protons, neutrons, electrons are and how we find their numbers.